So I want to take you through a few practice questions on Delta Math. I know they have their own help videos, but sometimes I think you can get a little bit more out of hearing me talk about it. Plus, I want to ensure that I have an example of everything you could potentially see. So this section in Delta Math is called Finding Values from Integrally Defined Functions. So you are going to be giving a function, they're going to call it f pretty much every time, that's going to represent a definite integral. You're going to have one of the boundaries, I think it's always the top boundary, be a variable, and they're either going to ask you for f of a number, f prime of a number, or f double prime of a number. So they have kind of three different options. So I would like to take you through one of each, try to cycle through these problems until I find a good one of each one. So the first one, the easiest one, because it's the one we've done before, is what if they just ask you to find f of -5? So -5 is going to take the place of your upper boundary. So the first thing you'll notice is your boundaries are flipped as far as you have the lower and the upper. So you've got 5 to -5. So whatever answer I get, I do want to negate it. And I am looking at the area under the curve of G, and G is the picture they gave. So -5 is here, and +5 is here. So you are going to have to use some geometry knowledge to find area under a curve. So 1/2 base times height. Looks like my base is 2 and my height is 3, so I get 3. Now keep in mind it's negative because where it's located. And then I have a trapezoid, or if you want to split it up into a rectangle and a triangle, that's totally fine. I don't care how you break it down. The rectangle is the easier one. It's 4 by 6, so it's 24 and located above the x-axis. And then my triangle, 1/2 base times height. My base is 4, my height is 6, so half of 4 times 6, so that's 12. So we get 36 minus 3 that was underneath, so we get 33. However, because of that boundary issue, the answer they're actually looking for is -33. So I'm going to go on my answer, type that in. And I also want to show you kind of what they'll do. They do a lot of what we do. So if you need to see a couple of their examples, that could definitely help. They also mention about the negation of the boundary, or negation because of the boundaries, to get your answer. So that's the first type you could see. Next type you could see, I want to do a first derivative one next. There we go. All right, so this one says that G is G is your function, and your boundary, again, the upper boundary is X, and it wants G prime. So this is saying that I'm going to derive this function. These are actually going to be the easiest. When I want to derive this function, I get my original function. I get f of x. And you'll notice, since I'm just putting an x in, the derivative of x is 1. I don't even have to worry about an extra chain rule piece. So when it's asking for g prime of 5, what it's really asking for is, what is f of 5? Because g prime will just equal this original function, because the derivative and integral will cancel. I am given a graph of f, so if I want to find f of 5, it is just finding where my function is, since I'm looking at f, at 5, and I'm at -1. So these will be the absolute fastest ones that you'll deal with, because I don't even need to worry anything about area or geometry. And it will show you, I love the graphics they provide. So they're telling you that g prime is the same as f, because the derivative and integral cancel. So g prime of 5 is the same as f of 5. And again, we saw it on our graph, and we just need the y value. And then the last type is when they ask you for a double prime. Let me find one. Here we go. Oh, that one's too easy. Let me find another one. There we go. Well, it's fine. So this one, if I take the derivative of f, the first derivative, I'm going to get g of x, because the derivative and integral will cancel, and I'm just going to put the x in place of the t. If I derive again, that's going to give me g prime of x. So that's what we're looking for. We're looking for f double prime of 1, which is the same thing as g prime of 1. Now look at what you're given visually. You're given a graph of g. If you're given a graph of g and you're asked about the derivative of it, you're looking for the slope, specifically at 1. So you're going to go to 1 and look for the slope. Well, this is kind of an interesting example. I didn't do this purposely. This one has an undefined slope because of that sharp point. So I'm going to go down here and I'm going to click D and E. Let me see if I can find one that actually does exist, just so you can see that. Okay. Hopefully this one exists. So this one, you're trying to find f double prime. So the first thing I do when I derive once, the derivative of the integral will give me just the original function. When I derive twice, it's going to give me the derivative of the function. So if I want to find f double prime of -3, what I'm actually finding is the derivative of g at -3. You're given g at -3. You find the derivative by finding the slope. So my slope looks like it goes up 2, right 1. It's definitely a positive slope. Or sorry, right 3. Up 2, right 3. So my slope is 2/3. And there we go. And you can see that they did basically the same thing we did. So f prime is equivalent to g, f double prime is equivalent to g prime. So you're finding the slope of the tangent line. And since we can find it just by using basic algebra, we get 2/3, and that is our answer. So hopefully this helps you with anything that you could see in that topic.